In this lesson, we're going to discuss LiDAR and how it's used in remote sensing. LiDAR stands for light detection and ranging. The word ranging talking about a distance measurement. Generally, when we use LiDAR in remote sensing, it's from a manned aircraft, sometimes from a terrestrial vehicle. And LiDAR devices can be used to measure things on the Earth, such as there are now handheld LiDAR units that we can use to determine things such as what is in a room, for example. So if you walked in a mechanical room with all the equipment in there, you could use a LiDAR detector and know where everything is in that room. LiDAR is also used in self-driving cars to keep separation accurate between vehicles. So for example, if you were following another vehicle, it would always keep you the same distance between that vehicle and your vehicle. So when the vehicle in front stops, you would also stop, and so on and so forth. The way LiDAR works is basically we send out a group of pulses and we look at the reflectivity from these pulses, and so therefore this is an active measurement device and not a passive measurement device. The way a LiDAR system works is you send out tens of thousands of pulses and they strike the Earth, and then they are reflected back to a detector. Those pulses that go straight down and straight back, the primary pulses that we have, are then measured to determine the distance. We also will have secondary pulses that will come back, and they can be measured to determine other factors. So very simply, if we know the velocity of light and we know the time from when the pulse leaves the aircraft and it returns, we can therefore measure the distance from the aircraft to the Earth. We're actually measuring the distance from the aircraft to the Earth and back, so we divide by 2 to find out what the actual distance is. So for example, if we have an aircraft that's at 1,000 meters above the ground and it sends out pulses, and about 6 microseconds later that pulse will return. During this time the aircraft is flying, so it's moving forward. So if it was moving forward like something at 200 miles per hour, the aircraft would move on the horizontal plane about 1/100th of an inch. So the aircraft's not moving a long distance from the time the pulse leaves the plane and comes back to the plane. So therefore, we can pretty accurately measure the distance to a spot on the Earth. So we wouldn't know what the height of the aircraft is exactly, but we could use the LiDAR to determine the exact height. Generally, the LiDAR detectors are in the near infrared. But for water, we use green lasers generally. But most of the lasers that we use are going to be in the near infrared, and therefore they would not be visible to our eye. So on this slide, you can see we've given you some reference information where to get some data. So we've given 2 servers here that you can use for your base map layers. But the one that we're going to concern ourselves with is where is the LiDAR stored. So I've already loaded that into my computer, that location. So I'm going to switch screens and go to that location. And so here is Kentucky from above. We're using Kentucky data. Most states have a site that you can download LiDAR data from. And also there's federal sites that you can download from. So we're going to go to download point cloud, and it's going to open up for us a map. It looks like this is just a light blue color, but if I zoom in, and I'm just zooming in by scrolling my mouse, you can see these are actually rectangles that we have here, and each of those are an individual image that we can use for analysis. So we could search through here and find a place that we wanted, or we can use the locator And I'm going to search for the location of my office. So 1000 community College Drive. So it's came up here. I'm going to click on that. Give it a moment to generate. And I'm going to click here, and you notice I have an FTP link that I can download from. There's also a decompressing software that you need to download, because this will come in as a compressed file. The decompressor is a unique one that's just for LiDAR, and so therefore you're going to need to download this and install this piece of decompression software, and we'll talk about that in just a moment. So if I click download, give it a moment, and it has downloaded that image. You can see it over here on my left side of my screen. And the image has a number which is N087E223, which is north and east position in that grid, is what that is describing. That's going to be in my download folder, and then I'm going to need to decompress this. Let's go back to our slides and go to the next slide. I have opened up the decompression program and installed it. And you can see here that you can browse to where that data was. Well, normally if you're downloading something, it's going to be in your download folder. So that's where I'm going to browse to, is my download folder. I'm going to find this tile that we downloaded and decompress it. So I'm going to press the decompression button here to decompress it. And then when I'm done, I'm going to press the quit button, and I will have downloaded and decompressed this tile. Now you could use more than one tile. For our sake, we're only going to use a single tile. If you use more than one tile, you'll want to do some mosaicing of the information. So I'm going to talk a little bit about this, and then we're going to go actually out and do it. So we're going to open Arcgis Pro. This is just bringing a base image in, so we're not going to worry about that right now. And that's what this is, also bringing a base image in. This is 2-foot resolution base image. But again, we're not going to worry about those right now. What we're going to do is concern ourselves with creating a LAS data set. So I'm going to switch to Arcgis Pro. So the first thing we're going to do is open the Geoprocessing window. The Geoprocessing window is under View. Then we select Geoprocessing, and notice this has opened up. There's the Geoprocessing window. And what we want to do is find the LAS data set that we brought in and bring it into our map. So we're going to type here create space LAS data set, and wants to know the input file. So I need to go find that input file. It is in my download folder, and it's actually not in a subfolder. There it is. Notice N087E223. Now the extension is LAS, but we've decompressed it. I'm going to say OK. It's going to read that file. It's going to create for me a named file, which is going to be the output, and it's going to have an LASD extension. Notice the coordinate system comes in for me because this was already projected data. We're going to, if this was not checked, we want to make sure we compute statistics, and we want to create a PRJ file. We'll use all LAS files, so we always create a PRJ file, and we're going to click Run. depending on the speed of the computer, will depend on how long it takes this to occur for you. I have a fairly fast computer, so we have actually seen it already run. Let's not worry about the colors at this moment, but if you look over on your left-hand side, you'll be able to see the newly created file. So these are our data points. We can zoom in on this if we want, and we'll see the individual points a little bit more carefully, all the little dots there. And this is elevation data that we're looking at. So there's the complete tile that we brought in. So we have the extent of our LAS data. Notice there is some new toolbars that have been opened. We're going to click on the appearance. And so we want to make some changes. So the resolution we want to be 1 to 1000. So I'm going to just choose that with the pull down. The number of data points we want to use is a little bit greater than what the default was. We want to use 5 million. We do not put the commas in. So I'll have 6 zeros there. We want to slide the density over to the maximum density we can have. And notice how that has changed our image, that we can see there is more data points now visible than when we started. We can look at the file boundary. And so we've just chosen that that's going to be red. That's the default. So you can see we have done some stuff there. We can also use the swipe system where we can swipe back and forth to compare what we're seeing between the base map. Now we're going to suggest to you that you have a imagery for base map, which we gave you some links to. For this case, I'm just using the topo as my base map. So next we want to look at the last points. We're going to use the pull down. And I want to look at the ground points. So I'm just going to select ground. So now it's only going to show me those points that are ground. So trees and things like that, it's not showing me. It's not showing me all the last points. We could go back to all points, or we could go to non-ground points. So we have some choices on what we can do here. But let's go to using the ground points for what we're doing right now. The next thing we want to do is we want to do a geoprocessing. So I've already got my geoprocessor open. I'm just going to go back to the search window. And what I want to do is create a 10. So we're going to put in here LAS data to 10. The input file is our LiDAR file. It gives us a name for the output file. If we don't like that, we can change it. The Z factor we can distort if we would like. And we're going to clip to the extent. And so we're just going to run this. And it's going to generate a 10 for us out of this data set. And this 10 is only going to be of the ground because we have chosen only ground points. So you can see the 10 is being generated. The next thing we want to do is again do a geoprocessing. We want to go LAS data set to raster. This is going to make a dim for us. I'm going to choose to use the original data set here. It gives me an output name. We want to use triangularization here. And we're going to use natural neighbor. And we're going to use no thinning. The smaller the sample size is, the better our data resolution is going to be. So I'm going to use 1 for that. So I'm just going to delete the 0. And I'm not going to stretch the Z direction. So I'm going to again tell this to run. And again, it's processing, if you notice here, nearly 4 million points. So it takes a few moments for it to process that. It looks like it's about to finish the processing, so it's doing an update. And you can see that we've now created a digital elevation model from what we had as data. The next thing that I want to do is I want to do a profile. Again, I'm going to do this in the geoprocessing window. So I'm going to come back over here and I'm going to just start typing profile. And there it is. So we'll choose that. I'm going to turn off, before I go any farther, these layers that we've created. It looks like this is sort of the highest area, and this area here is the lowest area. So we're going to make a profile. So we're going to draw a line for our profile. It's going to be just a very simple line. We're going to go maybe from, let's say here all the way up through there. So that's going to be, I need to double click on that to finish it. So that's going to be my profile line. So you see the name has now been put here. I can choose, I could have done multiple points on my profile. I just did 2 points from one end to the other end. On my dim resolution, I'm going to choose finest because I want to see as much change as possible, because we don't have a lot of elevation change in this image. If we were in eastern Kentucky or the western United States, we'd see a lot more elevational change in a single tile. And we're going to work in meters. And I'm going to say run. And so it's going to create a profile for me. So it has completed that operation. We're going to go to the data tab here. We're going to say create chart here. And what we want is a profile graph. So I'm going to click on profile graph. And so you can see it's created a graph. Let's stretch this up a little bit so we can see it a little bit better. And so therefore we have created a profile. You can see it's flat and gradually goes uphill till we reach sort of a peak up in here. It goes back down a little bit. That's actually a road, and then goes back up. So we have a horizontal distance and an elevational change. Remember, the elevational change was in meters, and so we can see what was going on with the profile. So I'm going to close my profile. I'm going to go back. Close my chart properties. I'm going to go back to the basis on where I was before, and let's drag this over a little bit. Okay. The last thing we want you to do in this lesson is to create a contour. So we're going to use our raster image. So I'm going to select that. I'm going to turn off our profile lines. And I'm going to select the dim that we created. Go back to the geoprocessing window where we type contour. And we're going to select a contour from a raster surface. We're going to use the raster as our input. There's our output name. The contour interval, we're going to set to be 5. That's 5 vertical units. It's going to be our variance in contour. We're not going to stretch the Z factor and the type is going to be a contour. And we're going to say run. And it's going to build us a contour map for us. So you can see the contour that's built for us. I'm going to turn off the raster, and you can see the elevational areas. You can see where the high spots are, the low spots. Notice the buildings aren't really showing up here because we're doing this off of ground. If we chose to do this off of all returns, we would see a slightly different contour, but it would have things like tree heights and heights of buildings and things like that in it. So this is based off of ground-based points, these contours. So these are some of the things we can do with a LiDAR image. So we want you to experience those same type of factors and play with doing these type of things with a LiDAR image.